Exercise 5. Develop a math model for the problem. Describe the type of math problem that has resulted. Using assistance from the TI-Nspire CAS, solve the math problem and interpret the solution. A nutritional consultant is planning a ham and provolone cheese sandwich for a high school cafeteria. As for the ham and cheese combined, they are required to have at least 200 calories in order to prevent students from craving sweets immediately after lunch. For nutritional reasons, the ham and cheese combined is to have no more than 10 grams of saturated fat and no more than 900 milligrams of sodium. Also, there is to be at least 13 grams of protein. Finally, the ham and cheese slice is each to be at least 20 grams. If the cafeteria can purchase ham for $6.59 a kilogram and provolone cheese for $5.89 a kilogram, how many grams of ham slice and grams of cheese slice will satisfy the requirements at the least cost? Round final answers to the nearest gram or cent as appropriate. For reference, the nutrition fact labels for ham and provolone cheese are provided. Okay, to get started here, let's see, what shall we choose for variables? One hint at what might be effective is to actually take a look at those provided nutrition fact labels. If you take a look at a nutrition fact label, the whole basis of all the information is based on one serving as defined in the top line of the nutrition fact label. Okay, that being the case, we might decide that it's actually a reasonably good idea to choose as our variables the number of servings of each of these. In other words, perhaps we come in here and we say, let's let x equal the number of servings of ham. Similarly, we let y equal the number of servings of provolone cheese. The key quantity here is that cost, which we're trying to minimize, right? Okay, so we furthermore let c equal the cost of ham and cheese, to be a little more specific. And what about that cost? The one type of information we have here for cost is that the cafeteria can purchase ham for $6.59 a kilogram and cheese for $5.89 a kilogram. Okay, how are we going to get this in terms of our variables x and y? Well, again, x number of servings of ham, y number of servings of provolone cheese. Let's see exactly another way of thinking of what that serving is by looking at the nutrition fact labels again. Okay, one serving of ham is 28 grams serving size. For provolone cheese, the serving size is, okay, a coincidence here, 28 grams as well. Okay, this gives us a way to get a hold of the information we need to formulate a cost. Okay, then we can come in here and we can say that we take our number of servings, in case of, as far as ham anyway, that's x, and then if we multiply that by 28, that gives us the number of grams of ham. Now, to make use of the pricing information, we actually need to know how many kilograms we have. Okay, no problem. Just divide by 1,000, and then we can multiply this by the per kilogram price of the ham. Let's see here, that's the $6.59 here. And then proceeding similarly for the cost of the cheese, we know we're going to have y servings. We multiply first by 28 to get the number of grams of that cheese. Then, realizing we need kilograms to make use of our price information, we need to divide that by 1,000, and then multiply that by the per kilogram price of the cheese. That's 5.89. Our price here is in dollars. Okay. And note here that we are trying to minimize cost. Okay. Now, the domain of this two-variable function here, what are the allowable xy pairs? Okay, so now we proceed to subject to getting our domain, or perhaps our feasible region. The term would apply if this is a linear programming problem. Okay, what have we got to concern ourselves with? Okay, physical sense, always a good starting point for this. Alright, and for physical sense, we have the real basic idea that you can't have negative numbers of servings of these things. You can have 0, you can have positive numbers, but no negatives. So, translating that means for physical sense, we're requiring x greater than or equal to 0, and y greater than or equal to 0. And to sort of keep track of ourselves, maybe we refer to this as our first inequality, or actually a pair of inequalities here. Okay, what else? Actually, since we're on to this physical sense idea, there was something in this problem that's so closely related to this, I think it might be a good idea to put this into the formulation right now, and that was back here, this little statement here. Finally, the ham slice and the cheese slice is each to be at least 20 grams. Okay, let's put that down as another subject to. Ham slice, cheese slice, at least 20 grams. What can we do with that as far as formulation goes? Alright, we're using number of servings as the basis. So we could take this idea of 20 grams and convert that into what kind of serving that is. Again, using that 28 grams as the basis for a serving size. So in other words, claiming you have a 20 gram ham slice, that is equivalent to saying you're going to have x greater than or equal to 20 over 28. And okay, this simplifies a little bit, right? Factor of 4 cancels 5/7. Similarly, the y greater than or equal to, now the cheese slice has also 28 grams for its serving size, so here we get the same number here, and that's 5/7. Okay, inequality type 2. Alright, let's see, what else have we got here? I just wanted to talk about that since it's kind of closely related to the physical sense idea there. So those two can kind of go together, and you furthermore can realize that this requirement sort of takes over this requirement. It's more strict. This was going to keep us in the first quadrant of the XY coordinate system, basically. This is going to push us further into it. Okay, so really this we can pay attention to, and this we can sort of ignore since it's redundant once we have seen these pair of inequalities. Alright, what else is going on in this question for restrictions on XY? As for the ham and cheese combined, they are required to have at least 200 calories in order to prevent the students from craving sweets immediately after lunch. Okay, so that would be provide at least 200 calories. Okay, how can we translate that? Alright, here's where we need to go back to the nutritional fact labels. As for calories on the ham, a single serving is 46 calories. And so what will that mean when you have X servings? 46X is the number of calories coming from your ham. And looking now at the provolone cheese nutrition fact, looks like there are 98 calories in a single serving. So for the overall provolone cheese calories, that would be 98 calories per serving times Y servings, 98Y. Okay, let's formulate that. 46X plus 98Y must be greater than or equal to 200. Okay, we could consider that inequality 3. Now we are planning to use some technology, the TI-Nspire, to be solving this. So as we have this here, we can sort of anticipate the idea that we're going to need to have a y solved for in this in order to use the TI-Nspire. So maybe we take care of that step right now. And as far as any other kind of simplifications goes, unless they do something dramatic, I tend to just leave it like this, since the calculator doesn't concern itself with whether it has to divide something by 98 or 49 or whatever. It doesn't really help it too much. So just directly solve this for y without doing much else. And let's see, we would subtract 46x from both sides, then divide both sides by 98. We have then y greater than or equal to, parenthesis, 200 minus 46x divided by 98. Okay, that could be 3a. Alright, let's look for another requirement here. Okay, back up to the problem statement. Here's a sentence here that follows the calorie restriction. For nutritional reasons, the ham and cheese combined is to have no more than 10 grams of saturated fat. Okay, time to go back to the nutritional fact labels again. Okay, careful now. It's saturated fat we're concerned about, not total fat. Alright, in the case of the ham, we're looking at one serving having 1 gram of saturated fat. In the case of the provolone cheese, we see there that one serving has 5 grams of saturated fat. Let's turn that into a formulation. Okay, first in words. Contain no more than 10 grams of saturated fat. Okay, so we saw there was 1 gram in one serving of ham, so 1x plus and 5 grams of saturated fat in one serving of the provolone cheese, 5y, and that is to be less than or equal to 10. Okay, could call that inequality 4. And then we can anticipate using the TI-Nspire, and we'll need to have y solved for in that case. So let's go ahead then and proceed one more step with this and subtract an x from both sides, then divide both sides by 5. We're looking at y less than or equal to, in parentheses, 10 minus x divided by 5. Okay, call that 4a, derived from fundamental number 4. Okay, what else? That same sentence also says that the ham and cheese combined is to have no more than 900 milligrams of sodium. Okay, let's work on that. Contain no more than 900 milligrams of sodium. Back to that nutritional fact label. In the ham case, one serving has 365 milligrams. In the case of the provolone cheese, one serving has 245 milligrams. Let's formulate. overall, this will give us 365x plus 245y less than or equal to 900. Okay, we can call that inequality 5. Alright, again, we're anticipating the usage of the TI-Nspire, so let's get y solved for. Y less than or equal to, subtract 365x from both sides, then divide both sides by positive 245. We have, in parentheses, 900 minus 365x divided by 245. Call that 5a. Okay, anything else? Also, there is to be at least 13 grams of protein. Okay, so there we are. Provide at least 13 grams of protein. How to translate that? We need those nutritional fact labels again, and looking around for the protein information. It's down towards the bottom there, and the ham provides 5 grams for 1 serving, and the provolone cheese provides 7 grams for 1 serving. Okay, ready to translate that. So this will give us 5x for the overall ham protein plus 7y overall provolone cheese protein, and at least 13. Okay, we need greater than or equal to 13. You can call that inequality 6. We anticipate needing to solve for y in the very near future, and so that would give us, let's see, y greater than or equal to quantity 13 minus 5x divided by 7. Call that 6a. Looks like we are ready to take a look at our resulting math problem. Let's see, what have we got here? Here's this cost function. It's being minimized. It's optimization. This formulation, okay, a lot of constants. However, it's just variable x multiplied and divided by constants. Same is true for the y. This is a linear function. Okay, let's look at these inequalities here. We have a big system, however, each inequality is linear. Okay, you know what? And this is one of the things we're supposed to answer in this question. So here, our first answer of sorts here is to come out and just simply say this math model is a linear programming problem. So this math model is a linear programming problem. Okay, so we'll be able to solve this, and we'll be using the assistance of the TI-Nspire. And now let's think of something else before we go further. This problem, kind of complicated. And when we start graphing inequalities on the TI-Nspire, at a point it starts to become kind of confusing as to what the overall intersection is of all of the linear inequalities. So another strategy that I tend to use when I get to more than 3 inequalities, where it starts to become difficult to see which is the darkest region here, it gets confusing, is I'll actually graph the complement of every single inequality here. In other words, I graph what is not allowed to be in the domain. And if I go through all of that, and then I look for the resulting white region, which is the part that didn't get shaded by anything, that white region becomes the domain of the function. Okay, so it's graphing the opposite, so to speak, of everything that we have formulated here. Now, this can create a big source of error. You forget any instant, oh, I was supposed to graph the y less than instead of the greater than, and you mess up the problem. So when I'm doing this kind of thing, I'm also very careful to keep track of what it is I am doing. So now I'm going to come back and I'm going to put down in a contrasting color just what I actually intend to put into the calculator. Now, these first two inequalities, really, you only need to worry about these two. And so when x is greater than or equal to 5/7, in other words, that means you're going to have not, what isn't the case, not x less than 5/7. And similarly here, this is going to give us not y less than 5/7. Okay, that'll be the first consideration there. Now it takes care of the first two. Alright, now when we get to this calories restriction, what will we be graphing? Alright, if this is permissible, then we could say not y less than 200 minus 46x divided by 98. Okay, this one, when we graph the solutions here, as far as the graphing the rejected cases, okay, in other words, not y greater than 10 minus x divided by 5. Okay, this one here, we'll be graphing not y greater than 900 minus 365x divided by 245. And here we'll be graphing not y less than 13 minus 5x divided by 7. Okay, check over the all the nots, make sure that they're the opposite of the inequality. Reverse the sign and take away the equals to, and then rewrite the same. Otherwise, it looks okay, 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 okay. Alright, we're ready to take our formulation to the TI-Nspire. Okay, here we are at the TI-Nspire, and the first thing we would want to do would be to add a graphs application. Now, first thing might be to get the settings in order before we even go one step further here. And for one thing, if we look at this problem, it has us rounding final answers to the nearest gram or cent as appropriate. Okay, looks like that means 2 significant digits type rounding is what's going to be required to get the nearest gram and the nearest cent in this. And that being the case, I want to make sure that all of the input data has got at least 2 more significant digits than the 2 we're looking for. So perhaps I'll choose to, well, first let's get started on this settings. And let's go to the graphs first. Alright, again, we're looking to be finally rounding to probably 2 significant digits. So just to be sure we're okay here, let's get this at 5 significant digits for that. Another thing is that in the initial graphing of all this, we're going to have a lot of inequalities on this calculator graph to begin with, and so having the labels at least at first is probably a little too crowded for the graphing calculator anyway. If you're using your computer software, it's probably okay, but right now I'm trying to imagine that you're using just your calculator, not the computer software. So I'll also will automatically hide all the plot labels of all the inequalities to keep the thing from getting too congested at first. Okay, well that will be an okay for the graph. Now, what about the settings in general? There's going to be a spreadsheet for this, right? After we get the vertices calculated, we have to go and evaluate the cost function at each vertex. So what about that? We will also want to make sure this has got at least 5 or so significant digits. I believe the default here is 6. You know what? That's fine. That's plenty, even more than we probably need, which is okay. Alright, that's in order. Now, let's go back to our current situation. One other thing, maybe just right now, and that is, in this situation, we already know about the physical sense part putting us into quadrant 1, and in fact the minimal cheese and ham requirement even puts us sort of further into the first quadrant. So maybe we could at least start off with a coordinate system that doesn't have so much unnecessary areas like what we have right now. So perhaps we'll go here to the menu and go to the window zoom and go to those window settings, and let's see, maybe just a little bit of a negative x-axis so that the x-axis has got room to work with a little bit. So perhaps a negative 0.5. Tab down, x max. I'm just kind of guessing. It's hard to imagine there's going to be more than like 4 servings of x involved in the answer to this question. We are considering just a single sandwich here, so that should be ample. And scaling it one a piece will be nice. The y, the same kind of numbers here. I want to make sure I see the x-axis, so a negative 0.5 for a low y, up to about 4 perhaps, and scale it one a piece, and okay. Start like that. Okay, let's look at our first requirement here. It is the actually it's kind of interesting. It's not x less than 5/7. Now that's actually a vertical line. The boundary line is a vertical line, right? The x equal to 5/7 line, and that will not be graphable by using this f of x type inputs. So in fact, I think we escape that for a moment here and think of a new way to get the vertical line, boundary line here, x equals to 5/7. What to do? One way is to go to the menu here, and as a construction, choose a perpendicular line. Now, how will we do this? You know, sometimes if you are not sure what to do, you can go up here to where the little icon is for the perpendicular, and it'll tell you basically how it works. First, you're supposed to click on the line, and then the point through which the perpendicular should pass, or enter a parenthesis and then coordinates. Okay, now we're looking for a very specific vertical line here, which may be very important in our domain calculation. So we need to get this pretty much exactly right. So we will indeed be using a coordinate here. So we first need to click on the line and then put in the coordinate. Okay, let's try that. The line we have in mind is the x-axis. So click there. Now it says I'm going to put a parenthesis. Now the x-coordinate, well, that's where we need the 5/7. So 5 divided by 7, and enter. And 0 is the y-coordinate. Enter there. Okay, now we have our line there. First, I'm going to hit escape to put away the perpendicular drawing tool. Okay, this perpendicular line, it's maybe a little short, right? We were kind of hoping for a little longer. No problem. You come here, select on it. You can pull it up as long as you like. Okay, maybe there. Another thing is this may be a very important line, so I don't want it to sort of blend into the background here like it is with the coordinate system. I think I'm going to color this something very prominent like red, because I'm concerned it's going to be something important. Okay, there it is. And maybe in a future graph I'll actually put in a label for that as well, the x equals to 5/7 boundary line. Now, by the way, this is going to be something we actually have to remember, because the Nspire will not shade to the left or right of a vertical line. This is the one thing we have to remember. So since this was our boundary line and it was supposed to be x, not x less than 5/7, we are rejecting everything to the left over here of this line. So we kind of keep that in mind as we proceed to the problem. Okay, now let's go on to the other inequalities. The next one is the twin that kind of goes with this, not y less than 5/7. Okay, for that, that's regular entry line type material. So bring up the entry line there with a tab, and it's an inequality, so I'm going to delete that equal sign, and it's a less than sign we want, And now it's just the number 5/7. 5 divided by 7, and enter. Okay, there's that. Now let's go on to the that calorie restriction, the complement of it, the not. Again, I'm looking all at the red print on my formulation so that I don't get confused. That's why I make a big effort to use contrasting color and the word not, so that I stay focused on what I need in a complicated problem. And let's see, we'll need to bring back the entry line, and again delete the equality, and it is a y less than, okay, number 2. Now we have here in parentheses 200 minus 46x and then it is that quantity divided by 98. Enter. Okay, more deleted region. Keep going. The 4a requirement, the not version. Okay, need the entry line again. Delete the equality sign, and this time it is a greater than symbol needed, number 4, and we need 10 minus x in parentheses. That quantity to be divided by 5. Enter. Okay, keep going. Now we're on to this sodium restriction, and we're again graphing its complement, deleting what cannot be in the feasible set as we go. And looks like we need to bring up the entry line again, delete the equal sign, and this one is a greater than 4. Now in parentheses 900 minus 365x and that is then to be divided by 245. Okay. Alright, we have not got much left for a domain here, and we still have another inequality to work with. Okay, it is the protein, and we're graphing its complement, so let's pull up the entry line again. It's an inequality, delete that equal sign. This time it is a less than restriction, and it is the quantity 13 minus 5x. By the way, you notice I just put the 5x, which, because I know that a variable cannot begin with a number, it's okay to just do a 5x like that. But in general, you almost always want to put a multiplication sign between things when using the TI-Nspire, because it will give you headaches in some cases when you start putting like an x times a y together. It doesn't know whether that's an x times a y or whether xy is the name of a variable, these sort of things. But here, I don't have to worry about that, because I know when I start with a number like 5x has to be 5 times x, and I can get away with that. Okay, now, what about this quantity? It's divided by 7. Okay, it turned out to not actually have any further impact on our domain here. Okay, let's see here. Now, don't forget, that red line is a boundary line, whereas to the left of the red line is rejected from being in the domain. So as we see, our domain or feasible region is this leftover quadrilateral. I think I will do a little bit of zooming before I go further. I want to keep the x and y axis in sight. I seem to like that whenever I can in a graph. And so for that, I think I'll do a zoom box. It's sort of one of the most controlled zooms there is. Okay, first corner here. I want to capture the future feasible region, but not too much excess. Okay, maybe there. Okay, now escape to put away that tool, and now let's see. how shall we proceed? Okay, a couple of vertices we can get a hold of right away. Here and here. We can get these from doing... Okay, let's go to the Analyze graph and an intersection with this graph here. There can be a lower bound. As we glide over for the upper bound, the intersection starts to appear. This is the time to hit enter, and then we can even grab this text and move it more into sight for us. Okay, let's go here, Analyze graph, intersection, and there's the second graph we're intersecting this with. For a lower bound, let's say there, we move to the right to get an upper bound and watch for the intersection to appear. There it is. This is when you hit enter, and then you may want to move it to a visible location. Okay. Now, what about... Now remember, this red line is the boundary line for the x less than 5/7 rejected inequality, which means this is all no good here. We need to stay to the right of this red line. How are we going to get these points of intersection here? You can't use a analyzed graph intersect because this red line is not part of something that came from the entry line. This was something we drew in as a perpendicular construction. Okay, so we'll need to proceed a little differently. Let's get on this graph here and let's trace it. Start tracing. Okay, now the first thing I'm going to do is I'm going to put in the x that I want to go to. So that is a matter of pushing. Remember the that vertical line, that's x equals to 5/7. Okay, I want that for x. So 5 divided by 7 and enter. Okay, it brings it there, and then enter again to put the coordinates right on the graph, which is just what we want. Okay, and then we can escape from that trace and move these coordinates into clear sight, right about there perhaps. Okay, we need another point, another vertex is right there. We have to do the same kind of thing, but this time it's this graph that we need to trace. So right here, tracing, trace graph, and it has the same x coordinate we're after, so immediately we just put in a 5 divided by 7, enter, brings it there, and then enter again, posts the desired coordinates right there. Okay, time to hit escape to put away that tracing tool, but let's move these coordinates into a nice, easy to see location, perhaps right there. Okay, now making good progress. This would probably be a good time to bring out the polygon sketching tool so as to get our feasible region very clearly graphed. Okay, so for that I can go to the menu here, and as far as shapes go to a polygon. Now let's see, okay, here and there and there and there and back to there. Okay, there's our polygon. We can escape, put away the drawing tool itself. Now let's make this polygon really prominent because this is our domain or feasible region. So for coloring, fill color bright red, and also I want to outline it in bright red as well. Okay, so now we have that. Now, the other thing that I tend to like to do is to not have all kinds of distracting other colors running throughout the situation, I prefer to more or less delete all of that kind of thing. And so what I can do is I can come back to those entries and just turn them back into equalities instead. Okay, so it's just a matter of you kind of go back here and you put in the equality sign. Notice the multiplication dot appears to the right when you do this. I don't know why, but I do know you have to delete it. So I go up and delete that and enter. Then, continuing doing this, the second one, back here, delete that, go to equality, and up and back to delete the multiplication dot, and have that. Okay, here, okay, this one. Delete that, make it equality, get rid of the multiplication dot, have that. Okay, couple more. Let's see, this one. Delete that, 3, and then take out that. Enter. Okay, this last one to do. Back to delete that, turn it to an equality, forward back to delete that strange multiplication sign. Okay, bringing us to here. Now we have our domain, very uncluttered, just its vertices in sight. Now, although I would normally like to label the boundary lines, I would not. I'm not going to do that here because it's just too much congestion for the calculator display. I will later on move to a computer view, and then that will be much larger, and that's where I would put the labels for all of these boundary lines. The one thing that should go on this graph, though, and that is, the feasible region should get its labeling. So let's pull up the text here, and I can make a statement like feasible region is red. Okay, put that at the bottom of this graph, and that would be a reasonable label there. Okay, now that we have this, well, it's a linear programming problem, so we know that the minimal cost will be at a vertex here, and these are going to be complicated, messy calculations. It's no problem. It's time for a spreadsheet. Okay, so let's go here and go Control and add a page and make it a spreadsheet. Let's see. Maybe we give these columns titles here. Alright, let's see. This could be the X vertex. Here could be X vertex, so we could put X VERT. This I'll put Y vertex. And this column cost. Okay, now time to bring in those vertice coordinates from the graph to here. Okay, so it's going to be a bunch of copy and paste. Let's go back to the graph. Let's start perhaps here. Okay, when it's in blue, you can copy it. So Control C, then go back to the graph and Control V to put it in there. A little small shortcut here. This same X coordinate applies to two vertices, so while I'm sitting here, I'll also do a Control V there as well. Alright, back to the graph. Let's take this Y coordinate. When it's blue, it's ready for copying. Control copy, Control C. Back to the spreadsheet. Control V. Okay. Back to the graph. This one's Y coordinate. Control C to copy it. Back to the spreadsheet. right there, Control V. Okay. Now let's get the x coordinate for the one of these other vertices, like here. Blue, time to Control C. Back here, time for Control V. And then here. Alright, it's y coordinate, it's blue, Control C, and Control V. Okay, go to this fourth line here for the fourth and last vertex. 1.6 is, okay, such a simple number, we can just memorize that. Again, since this is recording 6 significant digits, if it just puts 1.6, that must be exact. 1.6. Okay, so no need to spend time using Control C for that. We can remember 1.6 for the x-coordinate and Control copy this y-coordinate. There. And there. Okay. So now we have our vertex coordinates all into the spreadsheet. Alright, let's go ahead and work on this cost idea here. Now let's see, what can we do? We need to go to the formula line here for the cost, and here's where we're going to go back and look at our formulation of this question. When we formulated the cost, it was the 28x divided by 1,000, and then there was a y later on in our formulation. Right now, we have a choice. We can either use xvert and yvert for x and y respectively, which is okay, or something that's actually a little simpler and only applies to this spreadsheet is the idea of you can also use A right here, because A refers to this column and B refers to this column. Both A and X vertex are right now like column matrices, basically. So you have two choices. Since A is just very simple, I'll use that. So in other words, cost will equal to, be defined to be, okay, I'm looking at our previous formulation. I see we had here a 28, and now I can use an A, and then can divide that by 1,000, and then multiply that by the 6.59. Then we have a plus. Now we have 28 instead of y. I'll use B, a name for that column, and then divided by 1,000, and then times 5.89. Okay, enter. All right. Here we are. All the various costs. Okay, so what we're interested in is, here it is. Here's the lowest number in this column, this 0.413072. All right, it's now getting time to start making a conclusion. Now this was the cost in dollars, so and we are to round to the nearest cent. So we're looking at a 41-cent minimal cost, and that comes from having 0.71429 servings of the turkey ham, and 1.7055 servings of the provolone cheese. However, the question didn't ask us how many servings. It required the ham and cheese to be stated in terms of grams to the nearest gram. Okay, so we have a little bit of work to do, but we're very close to our conclusion. For the conclusion, let's go to a notes page for this, I suppose. And I think the first thing we actually do before we get to state our conclusion is, we know we see 41 cents for the minimum cost, but we need to do a little bit of converting here with these numbers here. Right now these are just servings, but what are they in terms of grams? Brief review of those nutritional fact sheets again. Serving size for a ham, 28 grams. Serving size for the cheese, 28 grams. Okay, so that's just the kind of information we need to convert our servings back into grams. Let's do that. Okay, let's go with Control, adding a page, and it'll be a notes page this time. Okay, now here's what we can do. You could open a math box, or since you're using a variable right away, we're planning to use the xvert. Oh, by the way, okay, keep track of this. See, we are in the second line. Okay, second line. That's where our conclusive information is here. It's in the second line. Okay, so let's make a note of that. Now when we come here, we can select a variable xvert. Now that's a column matrix, so we need to refer to its second entry, and for that you got to use the square bracket, and then it's number 2, square bracket. Okay, this number here. Now we're going to now multiply this by 28. Enter. Okay, if you'd like this to look a little better, like right now it has that little arrow pointing to the 20.0001. Alright, let's try math box attributes. Okay, we would like to just see that say equal to for one thing. Another thing is we are now at the point of making our conclusive statement, so we actually don't need to see so many digits. It's probably time to just float 2 digits in this conclusion. Alright, so we have that. Now let's go here and we'll do the same kind of thing. Let's take the y vertex and multiply it by 28 as well. So it's back to select variables, y vertex, need a square bracket, 2, it's the second entry we need specifically, another square bracket, and then multiply by 28, and then enter. Okay, let's make this look a little nicer. So for the math attributes, same thing. Let's have the symbol be an equal to, and let's have just the 2 digits there for that. Okay, now looks like we're ready to make a final conclusive statement. We can say, therefore, the minimum cost is, okay, let's see, dollar symbol, 0.41, which is achieved by using 20 grams of ham and 48 grams of provolone cheese. Okay, now this is a major conclusion to this question, so let's go here and let's get our format to where we have here some bold script. Okay, maybe something like that. Okay, now the other issue that remains is some sort of checking over of this answer and make sure we seem to think it's pretty good. So for this, maybe let's control add a page and a few notes to talk about checking things over here. Okay, what can we do here? Well, something like this. You could think of your own experience in a supermarket, or go online and check out the supermarkets that way, and think about what you see as far as ham and cheese. And for a common sandwich, sliced ham at the grocery store, you could very well find a sliced ham package with ham slices that are actually about the 28 grams or so that are talked about in this problem. In other words, the serving size in this problem corresponds to about a 1 slice of sandwich style ham at a supermarket, sliced at about 1/16 inch thick. So that means that our 0.7 servings would be about 0.7 slices of that, which is a reasonable quantity. Secondly, the cheese at 29 grams also corresponds to a supermarket cheese slice of about 1/16 inch thick or so, something like that. And so having 1.7 slices of that is also pretty reasonable. Okay, so we can write that down. Okay, so there we've written down what we just discussed here. Ham serving size of 28 grams. It's approximately one slice of the ham sold at the supermarket. Thus, a 0.7 serving is reasonable. Similarly, the provolone cheese serving size of 28 grams, that's approximately one slice of sliced sandwich cheese sold at the supermarket. So having 1.7 servings, that seems reasonable there as well. Now, under the cost that we have here, is this cost just completely unrealistic, or is it some sort of reasonable amount as well? Okay, well, back to comparing to the basic supermarket sandwich meats and cheeses to get a grip on the kind of numbers we expect here. Okay, these ham packages, if you have the 28 gram slices, those are about 1/16 inch thick, a little bit on the thick side. Okay, so that package sells for maybe $5, right? Okay, so if you have about 10 slices in it, $5. Those supermarket slices are running at about 50 cents a slice. And as far as the cheese goes, okay, the supermarket cheese, when you have the 28 gram slices, they're reasonably thick, and the package, which has about 10 of those slices, runs around $3, something like that. Okay, so you have about 30 cents a slice there. Okay, so let's write up a little something about what's going on, at least at the supermarket, for the cost of this kind of sandwich. Okay, so as for the cost conclusion of 41 cents, back to the supermarket idea. A supermarket ham slice of the 28 gram variety sells for about 50 cents, while a 28 gram of provolone cheese sells for about 30 cents. So the conclusive ham and cheese, if purchased retail, would be approximately the 0.7 servings times the 50 cents plus the 1.7 servings of cheese times its 30 cents, running around 86 cents. Now, as the problem involves a cafeteria purchasing at wholesale food service prices, I think the 41 cents is a reasonable quantity there. Again, the cafeteria is purchasing large quantities at wholesaler. It's not the same as when you or I go to the supermarket. It's considerably cheaper, but what we're looking for is it's not supposed to be only 1% of what we pay, right? It's supposed to be a significant discount. So we'd like to see that the answer of 41 cents is reasonable, that we're not expecting a 4 cents or $4 type solution as well. We want this to feel correct when we walk away from the problem. And so we have that at this point here, I believe. The very last detail would be going back to that first graph. Okay. Now, in the calculator, if you only have a calculator, this is about the best you probably can do without making things too congested. However, if you're submitting this solution to a client, you might want to do something a little more professional, and that's will be labeling these lines with their equations, right? Okay, so for that, we'll go to the I'm going to go to the computer view, but before I do that, here's what I'll do. I will go to the settings, and in that graphs, now we've been right here automatically hiding the plot labels because it just puts too much information into a little tiny graph area. Now we release that restriction. Let's have all the plot labels appear. Okay, as you see, it could look quite messy right now, but that's because we're just in the calculator view. Let's now move ourselves to the computer view, and I will also make this much larger. Okay, so now we have this much larger computer view, and now we start touching up some of the details. So these vertices get moved around when we've expanded the size quite a bit. So let's put them back right where the person looking at this can easily read them. Another couple things here. This was text saying the feasible region is red. Now there's enough room to label it, I think, more directly. So I think coming here and simply having a feasible region, labeling, and putting it now right in the feasible region. That looks a lot nicer. And this vertical line, let's put it doesn't get labeled because it's not from the entry line there. So let's do this. Go to text and record its equation this way. This is the x equal to 5 divided by 7. Enter that. So that can go right there by that vertical line. And okay, that looks pretty good there. So at this point, it's time to start taking snapshots, capturing images of these pages. Okay, we now have this page. I think the other pages we can use the calculator view to snap those. Okay, don't need this anymore. This one. Okay, this here. Capture that page. Our conclusion page. Capture that. And our checking page. Okay, the check was a bit lengthy. It needs to. You can either take 2 photos here, or you could actually just go back to the computer view and okay, capture all that. We are done. Very good.